Okay, today we're going to be continuing our 8.2 notes. When we left off last class, we were on the top of page 4. Okay, it says, will a trig ratio for a particular angle measure always be the same? The answer is yes, and that's because of trig and similar triangles and how they work together. Okay, so this little diagram says if two triangles are similar, then their corresponding sides are proportional and their corresponding angles are congruent. Okay. So what that means is that if this small triangle, for example, was a 3, 4, 5 triangle, and this big triangle was a 6, 8, 10 triangle, then if we took the sine, the cosine, or the tangent of both of these triangles, they would be the same because they are similar. So let's test that by using the sine. So if I take the sine of the small triangle, the sine of this triangle is equal to, and remember, sine is opposite over hypotenuse. So our opposite is 4 and our hypotenuse is 5. So the sine is equal to 4 over 5. Then if I took the sine of the big triangle, remember it's still opposite over hypotenuse, so we'd have 8 over 10. So 8 over 10, but 8 over 10 does simplify. That simplifies down to 4 over 5, which is the same thing that we got for the small triangle. So it doesn't matter which trig function we use, sine, cosine, or tangent. If they're similar triangles, they're always going to have the same angle. Okay. Now we're going to talk about using our calculator to find trig ratios. Okay, so since trig ratios for a particular angle are always the same, your calculator has been programmed to know the trig ratios for all angles. We use the trig button on your calculator to find the following. Okay, so on your calculators, there's a sine button, a cosine button, and a tangent button. If you push sine and then put 43 and enter, then you'll get an answer that looks like 0.6820 if you round 4 decimal places. If you did not get an answer that looks like that, then your calculator might be in radian mode. And so you'll want to switch that to degree mode, and then you'll get this as your answer. Okay. Then if we use the cosine button and do the cosine of 12 degrees, we'll get an answer that looks like 0.9781. And similarly, if we use the tangent button and do the tangent of 89, we'll get 57.2900 if we round to 4 decimal places. Okay, so now let's get into what we are going to be using these for. So we're going to need to use our calculator for the sine, cosine, and tangent of specific angles, but we're going to do something similar to last time. Last time we talked about identifying which angle you need, labeling your sides, and then using a trig ratio to find your ratio. This time, we're going to add a little bit more onto that, okay? So we're still going to be, if we look down here, number 1, we're going to be identifying our angle still. We're going to identify the sides of the triangle, and then we're going to have to decide which ratio to use, sine, cosine, or tangent. Now, after this is the new part. We're going to set up an equation, and then we're going to use our calculator to evaluate, okay? So, what does that look like? Okay, well, here's some examples. We'll look at example L. So it says solve for x and then round to the nearest tenth if necessary. Okay, well, the first step is always identify my angle. I'm always going to use the angle that it gives me. It gives me this angle of 23. So that's the angle I'll be using. And then I need to label my sides. That's step 2. Okay, so I want to label my hypotenuse. It's always across from the 90-degree angle. Then I want to label my my adjacent, because it's always touching this angle right here. So this would be my adjacent. And then I would label my opposite. That's the one that's left over. Okay, now that I've completed step 2, now I need to decide which trig ratio to use. Okay, well, remember our little acronym, SOHCAHTOA. SOHCAHTOA. Okay, well, right now we've got a number for our hypotenuse and we've got a variable for our opposite. So we need to use the trig function that uses opposite and hypotenuse. Well, that would be the sine function, opposite over hypotenuse. So we are going to be using sine in this case. So now is for the new stuff, we're going to be setting up an equation. So I'm going to start by saying the sine of my angle, and my angle is given to me. Remember, it's this 23 degrees. So the sine of 23 is equal to, and now I need to set it up equal to my ratio, just like I did last time. So opposite over hypotenuse. The opposite is x. So I'm going to do x over the hypotenuse, which is 3.2. So x over 3.2. Okay, now the next step is to solve this equation. I'm going to solve this equation just like I was doing in 8.1 by cross multiplying. So I'm going to put the sine, or my whatever my trig function is, over 1, because we can always put anything over 1, and that will help just distinguish what I'm multiplying everything by. So now I need to cross multiply. I'm going to end up with the sine of 23 times 3.2. So that looks like 3.2 times sine 23. That's going to be equal to x times 1, which is just x. Okay, and now I want to make sure that x is all by itself, which in this case, x is by itself. This means I can just put 3.2 times sine of 23 into my calculator, and it'll give me my answer. If I do put that in my calculator, it gives me 1.3 is equal to x when rounded to the nearest tenth. Okay, now looking at example M, we're doing the same thing. We're solving for x. So step 1, identify my angle. My angle is 65. Step 2, label my sides. Label my hypotenuse first. I'll label my adjacent second because it's always touching that angle. And then I'll label my opposite. Okay, step 3, identify which trig function I need to use. Well, right now I've got a hypotenuse and an adjacent, which means I need to use whichever trig function has hypotenuse and adjacent, which is the cosine. So we'll be using cosine for this one. So that's going to look like the cosine of my angle, which is 65 degrees, is going to be equal to my ratio, which is adjacent over hypotenuse. So we've got x is our adjacent and 7 is our hypotenuse. So x over 7. Now we're going to cross multiply. We've got the cosine of 65 times 7. So 7 times cosine 65. That's equal to x times 1, which is just x. Because x is all alone on this side of the equation, I can just plug this into my calculator. 7 times the cosine of 65 is equal to 3.0 when we round to the nearest tenth, and that's what x is. Okay, looking at example N, this is solve for x. Go through our steps. Step 1, identify our angle. It's 58 degrees. Step 2, label all of our sides. Hypotenuse never moves. adjacent is always touching my angle, and the opposite is what's left. Now I need to identify which trig function to use. I've got an adjacent and I've got an opposite. So if I look back up here, what uses adjacent and opposite, that would be the tangent function. So I'm going to be using tangent in this. So I'll start by saying the tangent of my angle, which is 58 degrees, is equal. And now I have to do my ratio. Tangent is opposite over adjacent. So I'll do x over 59. And now I will solve for x. Put this over 1 so I can cross multiply. I'm going to end up with the tangent of 58 times 59. So 59 times tangent 58. And that's going to be equal to x times 1, which is just x. Now we make sure x is all alone, which it is in this case. And so we can just plug this into our calculator and we'll get our answer. 59 times the tangent of 58 is going to be 94.4. And that's what x is equal to. Okay, let's do one more example. Example O. First step, identify our angle. Second step, label our sides. This is our hypotenuse. Our adjacent is always touching our angle, and our opposite is what's left. Okay, now step 3, identify which trig function we need to use. Well, we're using our hypotenuse, and we're using our adjacent. So if we look up here, hypotenuse and adjacent, that's cosine. So we're going to be using cosine for this function. So we'll say the cosine of our angle, which is 64, is equal, and now we'll do the ratio. Cosine is adjacent over hypotenuse. So we've got 3.7 over x, 3.7 over x. And now step 4, solve, or step 5, excuse me, solve for x. So we'll put that over 1, and that will cross multiply. We'll end up with cosine of 64 times x. So it'll look like x times cosine of 64. That's going to be equal to 3.7 times 1, which is 3.7. Now we need to check and verify that x is all by itself. It is not by itself in this case, so we need to make sure x gets itself. How we do that? Well, if I put the cosine of 64 into my calculator, it's actually just a number. Could be a big number, could be a decimal, I'm not too sure, but it's just a number. Which means I basically have a number times x. Now, when I have a number times x, what I would do to get rid of that number is divide it because it's being multiplied. So I can do the exact same thing, even though it looks like a cosine or a function. I can still divide both sides by 64. When I divide both sides by 64, these cancel with each other. And I just end up with x is equal to 3.7 over the cosine of 64. And now x is all by itself on one side of the equation. So now I can put 3.7 divided by cosine of 64 into my calculator. And that'll give me x is equal to 8.4. Okay. So that's why we're always checking to make sure x is by itself, because sometimes we'll end up multiplying and sometimes we'll end up dividing. Okay. Now, examples P and Q are going to be partner practice. Okay. If you're not here today, you'll just have to do those on your own and then come get them checked off. Okay, and then there's a Delta Math Online.